Alright, welcome to our next lesson about polynomials, which is dividing polynomials. We've multiplied, we've added, now we're going to divide. We can use dividing polynomials as a way to factor polynomials, if possible. But usually with x squared, with quadratics, we don't really worry about actually doing a division. But with higher order polynomials, x cubed, x fourth, x to the fifth, often we do. And so this is the last thing we'll do this semester. And so first thing we're going to start with is polynomial long division. Now what's important about this is that it can be used to divide any type of polynomial. So I want you to notice this is particularly important right here. It doesn't matter. This can be used anytime, long division. Okay? Now, that's not true of synthetic division, which is the second part of this lesson. But if you can always do long division, it doesn't matter. The dividend and divisor have to be in standard form. Okay? Now, what that means in terms of standard form, what that means is you've got your descending powers of x. So, I'm going to write here, that means put it in descending powers of, and I'm not going to say x, I'm going to say of the variable. Because it might not be an x, it could be something else. Okay, so we're going to put it in descending powers of the variable. Alright, and all degrees have to be represented. What that means is, say I've got x cubed and then an x, I'm missing an x squared, we have to put that in there. And as a, as a placeholder, so to speak. So I'll show that to you as we work the problems and the examples. And it's very similar to long division with numbers. So what I want to go through first is to look at an example of long division with numbers. So let's look at something like 647, and I'm going to divide that by 5. Now we look at first and see how many times 5 will go into 6. And that will be 1 time. Then we multiply the 5 and the 1 and put it underneath the 6. Okay? The next thing is you change the sign of the 5. And I'm going to say that instead of saying subtraction because that's what we do in our long division. But in essence, you're subtracting, so it becomes now a negative 5. And 6 minus 5 is 1. Our next step is to bring down the next number, which is 4. And so 5 will go into 14 2 times. 5 times 2 is 10. We're going to change the sign and then add them. So that's a 4. Bring down our 7. And then 5 will go into 47 9 times. And 9 times 5 is 45. We're going to change our sign and then add them together, so that leaves me with 2, and that's a remainder. It didn't divide evenly, it's a remainder of 2. Now you can write this a couple different ways. You can write your answer as 129 with a remainder of 2. You can write it 129 and 2 over the divisor, which is a 5, 2/5. Or it could also be 129 plus 2/5. Now, on your homework, you might see where it asks for the quotient, which is this part right here, and the remainders is 2 separate boxes. Or it might list it as wanting a polynomial, which you'd write it probably like this. So, pay attention on your answer, on your homework, which you want. You've got a online homework for long division on My Open Math. Okay, so we're going to go to the next page, which is the steps for polynomial long division. Be sure everything's in standard form. Write it as a long division problem. We just gave you an example. Divide the first term of the divisor into the first terms of the dividend. The divisor's what's on the outside, the dividend's under the symbol, and then multiply, subtract, or change signs and add. Bring down the next term, and then repeat the process till you're done. Okay, so let's look at what that looks like. We've got some examples, and I started with a relatively easy example. First question that you need to ask yourself, are all the degrees of the polynomial there? And so we notice we have an x cubed, an x squared, an x, and a constant. Descending powers of x, and they're all present. So then I'm going to go and just write what I've got. So I've got x cubed. Okay, so we've got x cubed plus 8x squared. Excuse me. Plus 8x squared minus 3x plus 16. And we want to divide that by x squared. Whoops, what happened? Go back. Got to start over, excuse me. Okay, so we're going to divide by x squared plus 5. And we're going to divide that into x cubed plus 8x squared minus 3x plus 16. Okay, now, the first thing we look at is this and this. What can I put up here in the quotient that would multiply by x squared to give me x cubed? Well, that would be an x. So how many times will x cubed go into x squared go into x cubed? Which is, we asked ourselves, how many times will 5 go into 6 in the previous problem? Okay, so x times. So x times x squared is x cubed, and you want these to be identical. But I'm not done because I have an x squared plus 5, so I also have to multiply the x times the 5. So that's plus 5x. So I'm going to, in fact, let me just erase this and rewrite this. We have a missing power of x in our divisor. So I'm going to rewrite it with, okay, so I'm going to rewrite it as x squared, get my pen back, x squared plus 0x, there's a placeholder for the x, and plus 5. Okay, so x times x squared is x cubed, plus x times 0x is 0x squared, okay, and then 5 times x is plus 5x. Okay. Now we're going to change the signs of everything. Now I'm going to change the color of my pen just to show you that I've changed the signs from what they were originally. So this now becomes minus, this becomes minus, and that becomes minus. All three of them go from plus to minus. Now we're going to add them up. So I'll go back to my black pen. X cubed minus x squared is 0. So this cancels out and adds to be 0. 8x squared minus 0x squared is 8x squared. And negative 3 and negative 5 is minus 8x. So I've added the together. Now I'm going to bring down the next term just like we brought down the next number. So I'm going to bring down the 16. Now, x squared and x squared match, so that I don't need another x, but I do need 8. So I'm going to say plus 8. 8 times x squared is 8x squared. 8 times 0 is 0, so that's going to be plus 0x. And 8 times 5 is 40, so it's plus 40. Okay? Now, I'm going to change the sign of everything. Okay, so this becomes minus, this becomes minus, and this becomes minus. Okay. Now, we're going to add these two things together. So there we go. These should add to be 0 because you matched them exactly, and then you change the sign. Negative 8 plus negative 0 is negative 8x. And negative 40 plus 16 will be minus 24, I believe. Okay. And that is our remainder. This part here is our remainder. Okay. So my final answer is going to look like this. Okay. It is going to be, let me erase this little stray mark here. It is going to be x plus 8 plus negative 8x minus 24 over x squared plus 5. And don't put that little placeholder in your answer. Just put the original divisor. All right, now notice that the numerator here is a lower power of x than the denominator here. It should be. If you ever get a remainder that has a higher power of x than your divisor, you've done something wrong. But we know we're good on this one. All right, so let's now go to another example. Okay. Again, we have all our powers of x represented, so that makes it a little easier. So we're going to write 2x to the 4th plus 3x cubed plus 5x minus 1. And we're going to divide that by x squared minus 2x plus 2. So what do I need to put up here, right in here, that will multiply to give me 2x to the 4th, and I multiply it by this x squared, the first term? Well, it'll be 2x squared. 2x squared times x squared is 2x to the 4th. Now I have to multiply it by this middle term in the divisor, minus 2x. So 2 times 2 is minus 4. And then x squared times x is x cubed. And be sure to line it up under the x cubed term. And 2 times positive 2 is 4, so that's plus 4x squared. And I did have a missing power of x that I didn't recognize. So I need to go back and do a placeholder. So let's erase here. Okay. And I'm going to have to put in a 0x squared, because I need that as a placeholder, and then the plus 5x minus 1. Okay, so now when I go back and multiply 2x squared times 2, I have 4x squared, and I have a place to put it. Last thing we need to do then, remember, next thing, change the signs. So I'm going to, this becomes a minus, this becomes a plus, this becomes a minus. Then we're going to add them together. These should cancel out to be 0. 3 and 4 is 7x cubed minus 4x squared. We've done our subtraction. Now we need to bring down the next term, which is plus 5x. Okay. Now, we've got 7x cubed and we've got x squared in the divisor. So if I multiply by 7x, 7 times 1 is 7. X times x squared is x cubed. Middle term here, 7 times negative 2 is negative 14. X times x is x squared. And then this last term, 7 times 2 is plus 14, and then x. Okay. Now we need to change our signs and then add. So this becomes negative, this becomes positive, and that becomes negative. Then we're going to add. This adds to be 0. 14 minus 4 is 10x squared. And negative 14 plus 5 is minus 9x. And then we bring down a 1. Okay. So that's our last term we have to bring down. So this is the last multiplication we'll do. What times x squared gives me 10x squared? So that we're going to put up in the quotient plus 10. 10 times x squared is, and that's a 1x squared, so 10 times 1 is 10, and then x squared. 10 times 2 is minus 20x, 10 times negative 2, and then 10 times positive 2 is plus 20. Change signs all the way across, so we end up with a negative here, a positive here, and a negative here. Okay. Then we need to add those two lines. First one adds to be 0. 20 minus 9 is 11x, and minus 21. Okay. Okay. So our final answer is 2x squared, okay, plus 7x plus 10, and then plus, and I want that last as a fraction, and it's going to be 11x minus 21 over the divisor, which is x squared, and that's the denominator in your original problem, plus 2. And so that's your final answer for this long division problem. Okay. One more example of long division, and this one's actually easier because it's got a linear denominator. So let's move on to our next example. When I say a linear denominator, you notice 3x plus 1 is just 3. It's an x to the first. We do have a missing power of x. Which one is it? I've got to go back. Excuse me. Oh, come on. Get back where I'm supposed to be. Okay, we're going to stop with this one, I think, as an example. All right, so we've got 9x cubed problems with my, there we go. Okay, so we've got 9x cubed plus 15x squared plus 0x. Remember, we're missing a power of x, so that has to be a placeholder. Minus 2. And then we're dividing by 3x minus 1. Okay. So 3 times 3 will be 9. So we put a 3 up here, and you need an x squared because we want to multiply to end up with an x cubed. So 3 times 3 is 9. X squared times x is x cubed. Okay. And then we're going to have to multiply it by the minus 1. So that's going to be minus 3x squared. Okay. Change our signs. It becomes a negative, and that becomes a positive. Then we add them together. That's 0. 15 and 3 is 18x squared. Bring down our 0x. Well, 6 times 3 is 18, so I'm going to put a plus 6. And then x times x needs to be x squared, so it's going to be plus 6x. Then when I multiply those two, 6x and 3x, I get 18x squared. And 6x times negative 1 is minus 6x. Change our signs. That becomes a minus. This becomes a plus. And add them. So it's really the same process as the long division of numbers. It's just, you've got x's in there. 0x plus 6x is 6x, and bring down the minus 2. And 3 times 2 is 6, plus 2. I don't need an x in the quotient, so 2 times 3x is going to give me 6x. And 2 times negative 1 is minus 2. Then when I need to subtract it, I'm going to change the sign and add. So change the signs. And then when I add them, you notice in this case, these all add to be 0, and so I don't have a remainder. So you can, with this polynomial division, still come out with a nice even division where you don't have a remainder. And so your answer for this one will be 3x squared plus 6x plus 2. And when you end up with no remainder, what it means is that 3x minus 1 is a factor of that numerator, the larger polynomial. Okay, so I've given you some examples of long division. I'm going to go, rather than do the next slide, actually, I think I may have already done this one. This one, there's some missing powers of x, but I'm not going to do that one. We're going to go with synthetic division. Synthetic division is easier, but you can't use it for everything like you can for long division. It has to be in the form of a factor x minus k, the divisor, the denominator. So in other words, you have to have just an x to the first. If there's an x squared or an x cubed in the denominator, you have to use long division. You don't have any choice. So the divid and the divisor, again, are in standard form, all degrees represented. This time you only use the numbers in front of the x's. You don't use the x's. And there's a remainder theorem. If a polynomial f of x is divided by x minus k, the remainder is f of k. And we'll talk about that later. I'm not so much going to talk about that now as the process of synthetic division. Okay, so let's look. We've got this big polynomial. This one I can't use synthetic division on. Why? So hopefully you got that right, that that's not an option for synthetic division. Okay, so now here's our steps. You list all the coefficients, then you bring the first number down, multiply it and put it under the next number, add your numbers. This time you don't have to change signs or anything, you just add them up, and you repeat steps 4 and 5 until the end. And your quotient has 1 degree less than your starting point, your dividend. So I'm going to work some examples. So here we've got x cubed plus 6x squared plus 2x squared minus 6x minus 9 divided by x minus 2. The tricky part here is this, what we divide by. We're going to divide by this number. Let me go back. You remember your factor when you did your roots? When you did your roots, your factor was x minus root 1. Okay? And root 1 had a different sign. So if it was minus, it was a positive root. And that's what you're dividing by. So in this case, you'll divide by 2. If it was x minus a negative, that's how you ended up with a plus in that factor. So what we're going to divide by is actually the root, which in this case is 2. First thing we're going to do is write our numbers in front of the x's. Again, they should be x cubed, x squared, x, and then a constant in order from highest to lowest. There's a 1 here if there's nothing. So we're going to write a 1. Then we write a 2. Then we write -6 and -9. And that comes from these numbers in front of the x's and then our constant at the end. So really we've got this x cubed, we've got x squared, we've got x, and we've got our constant. And we're going to divide by 2. Okay. So the process is this. The first thing we do is bring this number straight down and just write it there. Okay? So we write 1. Then we're going to take 1 and multiply it by our divisor. So we're going to multiply that by 2 and write our answer under the 2 in here. So that's going to be 1 times 2 is 2. So you write it right there. Then you just add those numbers. You don't have to worry about changing signs. So 2 and 2 is 4. Then we're going to multiply here. 4 times 2 is 8. Again, we're multiplying by 2 because that's our divisor. 8 times negative 6 is positive 2. 2 times 2 is 4, and that's negative 5. And this number right here is our remainder. These numbers we can put back as a polynomial, but they're one lower power of x than what we started with. So now this is our x squared, because we started here with x cubed. Then this is my x, and this is my constant. So the final answer is 1x squared, or just x squared, plus 4x, because that's a positive 4, plus 2, and then minus 5 over x minus 2. And you write that as the whole divisor. In your remainder, you don't put 5 over 2, you put 5 over x minus 2. Now let's look at that as long division, just to show you that it really does give you the same answer. I'm not going to do that for every problem, I'm just going to do it with this one. So we're going to have x cubed plus 2x squared minus 6x minus 9 divided by x minus 2. So up here we would have an x squared, and that would multiply to give me x cubed minus 2x squared. Change our signs. So that becomes a minus and a plus. Okay. Then this adds to be 0, and this is 4x squared. Now I'm going to have to put a 4x times x, and I'm going to bring down here my minus 6x. Okay. So 4 times x is 4x squared, and then minus 8x. Okay. Change our signs, negative and positive, and then add. Okay. So we end up with 2x minus 9, bring down your 9. And so up here we'll put plus 2, and that's going to give me 2x minus 4. Change our signs and then add. So this becomes minus and plus. Okay. Then when we add them, this adds to be 0, and our remainder is negative 5. And so you can see this plus our remainder is the same as we got doing synthetic division. And synthetic division is much quicker and easier to do. Okay. So let's go on to our next problem. Versus synthetic, we have, I think, 2 more examples. Now here we have missing powers of x. We've got x to the 4th, but we don't have an x cubed or an x. So we have to put those zeros in. So remember, we've got x to the, whoops. So we've got, we want to write x to the 4th, then x cubed, then x squared, then x, and then our constant. And we're going to divide by, to get this plus, remember that would be x that would be x, why is it not writing, there we go, x minus a negative 1, and that's our root, okay? So we're going to divide by a negative 1. Okay. Now our numbers that we're going to use a 3. There's no x cubed, so we put a 0 there as a placeholder. There's a 2 in front of the x squared. There's not an x, so that's another 0. And then the constant is a minus 8. So you have to have those placeholders there for those missing powers of x. First step, bring down this first number. So that's a 3. Multiply by negative 1. So 3 times negative 1 is negative 3. Add, negative 3 plus 0 is negative 3. Multiply by negative 1. So that's going to be a positive 3. 3 plus 2 is 5. Multiply by negative 1. So that's going to be negative 5. Negative 5 plus 0 is negative 5. And then multiply by negative 1, and that's a positive 5. And so that's, add that, and you get negative 3. So this is our remainder. Remember, these are lower powers of x, so this is now x cubed, x squared, x, and our constant. You go 1 power of x lower on all these terms. So my final answer is 3x cubed minus, because it's negative 3, x squared, plus 5x, because that's a plus 5, and then minus 5, and then minus 3 over x plus 1 for your remainder. Okay. Now I'm not going to put all of these arrows and things in this next example. We're going to see, and hopefully you can do it on your own. Okay, so let's look at our last example. No missing powers of x, so we're going to write 1, okay, we write 1, negative 5, 4, and negative 2. We divide by, remember it's x minus, so if there's a minus there, we're going to divide by our 2, positive 2. That's the hardest part. Remember, change the sign. You're multiplying by the root. Bring down the 1. 2 times 1 is 2. Add these so you get negative 3. Negative 3 times 2 is negative 6. You add those two numbers and get negative 2. And negative 2 times negative 2 is negative 4. And so you get negative 6 as a remainder. Okay? And so, since I started with x cubed here, this now, the bottom here, is an x squared. So it's 1x squared minus 3x minus 2 minus 6 over x minus 2. Or if you want to put plus negative 6 over x minus 2, that's all okay. That's fine. And that's your final answer. Okay, I hope that helps. I hope you're able to do this without any trouble.